Hello everyone. In this video, we're going to have the explanation about the OSI architecture. That is, it tells about the various layers that works behind the telecommunication that's happening. So we know about the data transmission happening between the sender and the receiver, but actually how it works, it has various functionalities. So all those functionalities can't be learned as such. So for easy management and the troubleshooting purpose, they have categorized all the functionalities under these seven layers, and every layer has its own uniqueness. So the control features will be there, and all those options will be added along with the PDUs. So every layer adds, as you can see in the picture from the sender side, starting from the application layer. The application layer header will be added along with the user data. So likewise, every layer adds its header, and then it is sent through the communication and transmission channel. And after, at the receiver end also, as you can see, the layer by layer a header will be opened and the control informations will be read. So finally it reaches the reduced PDU will be shown to the user as a high-end presentation. So there are seven layers starting from physical layer, data link layer, network transport, session, presentation, and the application layer. So starting with physical layer, as you can see the name, physical layer, it tells about the physical hardware. So we have different types of hardwares like the end devices, PCs, laptops, mobile, whatever it could be, servers. And then the point or the requirement to connect these end devices, that is through the cables. So we have different types of cables available, and also the connecting media can be of two things. So one is a wired medium and another one is a wireless medium, and we have various protocols as mentioned in the slide here. The second layer is the data link layer. So here the packet or the PDU is called as a frame, and the important functionalities of this data link layer include framing, flow control, error control, and congestion control. So framing, we all know the overall data is being divided into smaller frames according to the size of the MTU. And then what about flow control? The data or the number of frames that's been sent from the sender to the receiver. So how it can be regulated without affecting the drop of packets, without allowing drop of packets. And then error controller, during the transmission in the transmission channel, some bits might have been changed due to interference or any other reason. So how to detect these bits, these are called as the error bits, and how to detect and correct these things, those will be learned under this. Those are taken care of by this data link layer. And finally the congestion control, we have methods called as CSMA, CA, CD, Aloha, slotted Aloha methods to regulate the congestion that could happen in the transmission medium. So these all functionalities are being taken care of by the data link layer. And the switch, the device switch is called as a data link layer device. And then this data link layer is divided into two sublayers. One is a MAC layer, that is a media access control, that's the lower sublayer. And the another one is a logical link control layer, that is works along with the network layer, that is in touch with the network layer. So it interprets the signals as the data, including the timing synchronization and the error checking. The third layer is a network layer. So the network layer, the main functioning device in network layer is a router. So the functionalities of the network layer include two functionalities. One is IP addressing and the routing. Routing helps in creating a routing table with the help of algorithms, and then that only helps the routers to do the packet transmission within a WAN or to another network. And then IP addressing. So we have IPv4 addressing and IPv6 addressing. That's called as a logical addressing, and that is only the network layer attaches in its header information. So in data link layer, the data link layer device deals with the MAC address, that is the physical address. Here network layer deals with the IP address, which is the logical address or the temporary address. The next is the transport layer. So here it performs the end-to-end verification And here it selects the type of service, whether you want a connection oriented service or the connectionless service. Suppose your whatever your application, if your application is a live broadcast, then you want a faster broadcast only. So at that time you don't wait for retransmission, and also there you will go for faster broadcast. Hence connectionless service will be provided, UDP you will select. And if suppose you are sending a mail, and the file attachment is a very important aspect. So in this case, you will go for a reliability as the top priority, and hence you will go for the concept called as the TCP protocol for ensuring the reliability. Hence, such services have been selected in this transport layer protocol. Here, the socket plays a major role in it, and the types of ports. The port numbers also is there. It ranges from 0 to 65535. So all these port numbers help in giving an address, a particular address to the type of application that we are performing right now. And then coming to the session layer, this helps in establishing a session, managing, and then after the communication is over, then terminating the session. So in case of the connection oriented service, the session is very important in sending a transmission between the source and the destination. It's like an agreement between the source and destination during the communication. Then coming to the presentation layer, the key point in presentation, as the name says, it focus more on the presentation aspect. So particularly, it includes translation, and then translation refers to encoding, and then encryption. So converting data into some other format so that the intruder cannot read the actual meaning from the raw data. And then the last one is compression. So you can go for a lossy compression or a lossless compression in order to go for an optimal data transmission. And the last layer is the application layer. This is the top layer where this deals with the user directly. So this shows a high level of information. So all your data will be presented in a high level information. So everything at this layer is application specific. So this provides services for many services. We have email services, file transfers, and then remote communication using telnet. So we have various protocols as well. The telnet protocol helps in remote communication, FTP used for file transfer protocol, and so on. HTTP, we have World Wide Web. All these protocols provide the appropriate application that's required for our task. So these are the 7 layers in the OSI model. After that, we have they have derived the TCP/IP model, wherein we have got only the 5 layers. The top 3 layers are being clubbed together. The top 3 layers of the OSI model are being clubbed together and called as the application layer in the TCP/IP, and then the rest of the other layers serves the same purpose. So this is the overview about the OSI model and the TCP/IP model. Thank you.